Hello guys, welcome back to Electric Circuits. Good morning, Vinod Kumar. Good morning. So I think in the last session we have looked at what maximum power transfer theorem, and after that we looked at the Wheatstone bridge and also the extended Wheatstone bridge. Okay. So in this session we will look at another very important circuit theorem, namely the reciprocity theorem. Okay. This is what lecture 8. Okay, and today is 4th. So first of all, this reciprocity theorem can be applied to what? Resistive two-port networks. Okay. Reciprocity theorem it is applicable to what? Resistive two-port networks. Reciprocity theorem is applicable to what? Resistive two-port networks. So when it comes to reciprocity theorem, we will have what? A network which is purely resistive. We will have a network which is purely resistive. That means what? Inside this box, the only elements that we have are what? Resistors. Okay, we don't have voltage sources, we don't have current sources, and we also don't have any dependent sources. Okay, all we have inside the box are what? Resistors. Okay, so this box, it is what? Purely resistive. Okay, so let me write that it is what? Purely resistive. Okay, and resistive, what kind of network? Two-port networks. Okay, remember earlier we have studied Thevenin's theorem, which is applicable to linear one-port networks. Okay, any linear one-port network. If you are interested in voltage and currents outside that network, then you can simplify that linear one-port network into a single voltage source in series with a single resistance. Okay, but now we are dealing with resistive, not one port but two port networks. Okay, so these two terminals will form what? One port. These two terminals will form another port. I hope you remember the definition of a port. Port is what? A set of two terminals at which currents can enter and leave the network. Okay, so when will two terminals form a port? For example, if I call this terminal A and if I call this terminal B, so when will terminals A and B form a port? Let's say the current flowing into the network at one terminal is what? Some I1. Then the current flowing out of the network at the other terminal also should be what? I1. So at one terminal I1 is entering the network, and at the other terminal I1 is what? Flowing out of the network. Then only A and B will form what? A port. Okay. Similarly, if I call the other two terminals on the right side as what? C and D. So when will terminals C and D form a port? If the current flowing into the network at terminal C is what? Some I2, then the current flowing out of the network at terminal D also must be what? I2. So here for A and B, I1 entering, I1 leaving. For C and D also, I2 is what? Entering, I2 is what? Leaving. So in this way, C and D will also form a port. So altogether we have what? Two ports. Okay, so the two terminals on the left hand side will form what? A port, and the two terminals on the right hand side will also have what? A port. Okay, so we have what? A resistive two port network. Now at each port we connect what? A voltage, so independent source. At each port we connect what? An independent source. Yes, so this left hand side, I'll call it port 1, and the right hand side we'll call it what, port 2. So my point is what, at each port we are going to connect some independent source. What are the two independent sources that we have? Voltage source and current source. Yes. So at port 1 you can connect some independent source. At port 2 also you can, you have to connect what, some independent source. Now each independent source can be what, a voltage source or a current source. Okay. Now there will be three possibilities. Okay, at both the ports you connect what, voltage sources, that is one possibility. At both the ports you connect current sources, that is another possibility. A third possibility would be at one port you connect a voltage source, at the other port you connect what, a current source. So these are the three ways, okay, of connecting independent sources at both the ports. Okay, so this is what, an independent source. There is also an independent source, and each independent source can be what, voltage source or current source. Okay, so this independent source, it can be what, voltage source or current source. Even the other independent source can be what, a voltage source or a current source. Okay, so now we look at this reciprocity theorem for various cases. Okay, so this box again is what, a resistive network. And let's say for this resistive network there are two ports, one port on the left, another port on the right. Already I told you what, the port on the left is what, port 1, the port on the right is what, port 2. So this is port 1, this is what, port 2. Okay, so this is port 1, this is what, port 2. Okay, let's say we connect voltage sources at both the ports. In the first case, let's connect voltage sources at both the ports. Look at this. So at port 1 I connect a voltage source. At port 2 also I connect what, a voltage source. Now this voltage source connected at port 1 we'll call it what, V1, and the voltage source connected at port 2 we'll call it what, V2. Okay. Now at each port there will be two variables. At any port there will be two variables. One is what is the voltage across the port, another is what is the current flowing at that port. So at port 1 what is the voltage, what is the current. At port 2 what is the voltage, what is the current. Already at port 1 we have connected what, a voltage source. The voltage across port 1 will be what, V1, and the voltage across port 2 will be what, V2. So we have already labeled, we already have voltages at both the ports in the form of what, V1 and V2. Now we have to show the currents at both the ports. While showing the currents, we have to follow some standard convention. Now what is that standard convention? The current, because for current you have to show the direction. Yes, the current can flow like this, the current can also flow like this. But you cannot have any arbitrary way of assigning the current direction. You have to follow some standard convention. Now what is that standard convention of assigning the direction of the current at any port? The current direction is assigned such that the current flows out of the plus terminal of the independent source. Yes, or the current direction will be assigned such that the product of voltage and current will give you what, the power supplied by the independent source. I repeat, the current direction is assigned such that, yes, the product of the voltage and the current will give you the power supplied by the independent source at that port. Okay, so maybe I should type a statement. the current direction at any port is assigned such that the current direction at any port is assigned such that the product of the voltage and current at that port is equal to the power supplied by the independent source connected at that port. So that is how you assign the current direction. Okay. Now coming back to the circuit, I1 will be the current at port 1. Now the direction of I1 should be such that V1 times I1 will give you what? The power supplied by the independent source V1. Yes. So power supplied by any element is what? Voltage times current flowing into plus or out of plus? Out of plus. So this is how you mark the direction of I1. So here if you multiply V1 with I1, what do you get? Power supplied by the independent source connected at port 1. Okay. Other side also you show I2 in this direction. So this I2 with respect to what? This independent source V2, what is its direction? Into plus or out of plus? Out of plus. Out of plus, it means what? V2 times I2 will give you the power supplied by the independent source. Okay. Now for this, so this is what? The complete circuit or the complete network. Okay. So we have a resistive network which is being driven by two voltage sources, one connected at port 1, another connected at port 2. Also we have shown the two terminal currents I1 and I2. Now we have to conduct two separate experiments. So in each experiment, only one independent source is going to be active, the other independent source will make it 0. So in the first experiment, voltage source V1 will keep it active and voltage source V2 will keep it what? 0. Will make it what? 0. Okay. Then what is it going to be? So we have what? The original resistive network. At port 1, whatever voltage source V1 that we have, that will remain as it is. But at port 2, whatever voltage source V2 we have, that becomes what? A short circuit. Okay. Because when you make a voltage source 0, it becomes what? A short circuit. Now for a short circuit, only the voltage drop is what? 0, but the current need not be 0. Yes or no? For a short circuit, it's only the voltage drop that becomes 0, but the current, it need not become 0. Okay. So even through this short circuit, some current can always flow. Okay. So what is the direction of that current? If you look at the original circuit, this I2 in this branch is flowing in the upward direction. Yes, and I2 is what? Flowing in the upward direction. So here also in this short circuit, we take the same direction for the current, and that current is what? Some I2. So how can you measure I2? All you have to do is what? Connect an ammeter. Yes, in place of this wire, if you connect an ammeter, that ammeter will tell you how much is the value of I2. Okay. Now when it comes to reciprocity theorem, I already told you what? In any circuit, independent sources will act as what? Inputs. In any circuit, independent sources will act as what? Inputs. Yes. So in this experiment, right now there is only one independent source, that is what? V1. So obviously V1 is going to be what? Input. In reciprocity theorem, always the input of the independent source will be connected on one side and the output is always taken on the other side. So input is already taken at port 1, so the output will be measured at port 2. And at port 2 we have what? A short circuit. And for a short circuit, voltage drop is what? 0. Yes. but for a short circuit, current can always flow. So whatever current flows in the short circuit at port 2, that is what the output. And then in each experiment, we find the ratio of output to input. So what is the ratio of output to input in this particular experiment? It is what I2 by V1. What did we make 0 here when V2 is 0? So this is how you perform the first experiment. It is very simple. You take the original circuit, you make the voltage source V2 0, then you get a short circuit. You can measure the current in that short circuit. That current in the short circuit is what the output, and whatever voltage is applied at the other side, that is what the input. And we simply measure the ratio of, or find the ratio of output to input in the first experiment. In the same way, we have to perform another experiment. Already in the first experiment, voltage source V1 was active and V2 we made it 0. So this time V2 is going to be active and V1 we have to make it 0. Okay, see. So first I draw the resistive network and these are the 2 ports. Yes. So when you make V1 0, left hand side we have what a short circuit, and this time V2 is going to be active. So right hand side we have what, the same voltage source V2. I already told you wherever you have the independent source, that will act as what, input. So this time the input is on the right, so obviously the output is going to be on the left, and on the left side we have what, a short circuit. For a short circuit, we can always measure the short circuit current. What is the direction of current? In the original circuit in this branch, the current is what, flowing in the upward direction. So here also in this short circuit, I1 will flow in the upward direction. So what is the ratio of output to input? It is what, I1 by V2. It is what, I1 by V2. When what is made 0? V1 is made 0. That's all. So this is what the original network, and these are the 2 experiments that are conducted on the original network, and in each experiment we find the ratio of output to input. Now what is this reciprocity theorem telling us? This reciprocity theorem will tell us the relation between the 2 ratios, the 2 ratios of output to input. And according to reciprocity theorem, these 2 ratios are equal. That's all. According to reciprocity theorem, these 2 ratios are equal. What is the first ratio? I2 by V1 when V2 is made 0 is equal to what? I1 by V2 when V1 is made 0. That's all. This is what is reciprocity theorem. Okay. So in this particular case, at both the ports we have connected what? Voltage sources. In this particular case, at both the ports we have connected what? Voltage sources. Let us take another case where at both the ports we connect current sources. Okay. Once again, to start with, we have what? The resistive 2-port network. We have what? The resistive 2-port network. This time, as I said, we are going to connect current sources at both the ports. So at port 1, I connect a current source. I'll call the current source as what? I1. And at port 2, I connect another current source, and this current source I'll call it what? I2. Remember, in reciprocity theorem, there will be 4 variables. Okay. The 2 currents I1 and I2, and also the 2 voltages V1 and V2. Already we have I1 and I2. Now we have to show V1 and V2. I already told you the current direction will be such that the product of the voltage and current will give you what? Power supplied by the independent source. to get the power supplied, you should multiply voltage with current flowing out of plus. So this is what V1 and this is what V2. This is V1, this is what V2, okay. So now that we have the original circuit, for this original circuit that has two current sources, okay, let us conduct the two experiments just like we conducted for the earlier circuit, okay. So in the first experiment, the current source I1 will keep it active and the current source I2 will make it 0, okay. Current source I1, if you keep it active, this is what I1, and the other current source you make it 0. When you make it 0, it becomes what? An open circuit. And always across open circuit you can measure the voltage drop by connecting what? A voltmeter, which will act as what? Open circuit. You can measure this voltage drop, okay. And that voltage drop polarity is what? Same as the original polarity, which is what? V2. I always tell you what, in each experiment only one independent source will be active and that independent source will act as what? Input. So this time this will be the input. On the other side we can measure this open circuit voltage V2, which will become what? The output. And also I told you what, in each experiment we find the ratio of output to input. So what is the ratio of output to input in this case? It is what? V2 by I1 when I2 is made 0. What is the second experiment? The current source on the right side we keep it active and the current source on the left we make it what? 0. Okay. So I2, this time it is going to be active and the I1 current source we make it what? 0. So current source I2, if you keep it active, right hand side we have what? I2, and left hand side the current source I1, if you make it 0, it becomes what? An open circuit. And across that open circuit we can always measure the open circuit voltage, which is what? V1, and this polarity is same as what? This polarity. And now this independent source on the right side will act as what? Input, and this open circuit voltage on the left side will become what? Output, okay. And as I said, in each experiment you measure the ratio of output to input. So you measure the ratio of output to input. So what is the ratio of output to input in this particular case? Is it not V1 by I2 when I1 is what? Made 0? Yes. That's all. So for the original circuit, we have performed the two separate experiments, and in each experiment we found the ratio of output to input. Now this reciprocity theorem tells us what? The relation between the two ratios. Once again, reciprocity theorem tells us that these two ratios are equal. Okay, so earlier also the two ratios were equal according to what? Reciprocity theorem. Now also according to reciprocity theorem, the two ratios are equal. So according to reciprocity theorem, what is the first ratio? It is V2 by I1 when I2 is made 0. It is equal to what? The other ratio, which is V1 by I2 when I1 is made 0. That's all. This is what reciprocity theorem dictates. Okay. So what are the two cases we have seen so far? In one case, at both the ports we have connected what voltage sources, the two ratios are equal. In another case, at both the ports we have connected current sources, then also the two ratios are equal. Now we have to look at the third case where at one port we have what? At one port we have what? A voltage source. At another port we have what? A current source. Okay. So once again, to start with, we have what? Resistive network. Resistive two-port network. These are the two ports. Let's say at port 1 we connect what? A voltage source V1, and at port 2 we connect what? A current source I2. So in the earlier two cases, the same type of source was connected at both the ports. Current source, voltage source. But now at one port we have a voltage source, at another port we have what? A current source. Okay. You can also do it in another way. You can connect current source at port 1. You can also connect a voltage source at port 2. That is also one way to connect different sources at both the ports. Okay. Anyway, I told you what, there will be a total of 4 variables, V1, V2 and I1, I2. So already V1 is shown, so you have to show what? I1. The direction of I1 should be such that V1 times I1 will be what? Power supplied by the independent source. And at port 2, the current is already shown, you have to show what? The voltage. So if you multiply V2 with I2, you will get the power supplied by the independent current source I2. Okay. That's all. Now all variables are clearly shown. Let us again perform the same two experiments. Okay. So in the first experiment, the voltage source V1, it is going to be active, and the current source I2 will make it 0. So what will the network be like? So this is what the resistor. This is what the resistor. So voltage source V1 is kept active. So left hand side we have the same voltage source V1. Right hand side, when you make the current source I2 0, current source when you make it 0, it becomes what? An open circuit. But across the open circuit, you can always measure the open circuit voltage drop, which is what? V2. Now in each experiment, you will have input on one side, output on the other side. So you have input on the left side, because left side we have what? The independent source. So right hand side, this open circuit voltage will become what? The output. And then I always tell what? In each experiment, we measure the ratio of output to input, which is V2 by V1, when what is made 0 in this experiment? I2 is made 0. In the same way, let's perform the other experiment where the voltage source V1 is made 0 and the current source I2 is made what? Active. It is kept active. Okay. So this time the current source I2 is kept active. This is what? The current source I2. And on the left hand side, we have what? A voltage source V1, which becomes 0. Voltage source 0 means what? It becomes a short circuit. Okay. And for a short circuit, always the voltage drop is what? 0, but current can flow, and that current will flow in the same direction as I1 in the upward direction through this short circuit, which can be measured by connecting an ammeter in place of the short circuit, ideal ammeter. Okay. Now again, independent source is present on the right side. So the right side is what? Input, and whatever short circuit current that we measure at the left side, that becomes what? The output. And we always take the ratio of output to input. What is the ratio of output to input? It is what? I1 by I2. It is what? I1 by I2. When what is made 0? When V1 is made 0. Okay. When V1 is made 0. Now again, we have two experiments. In each experiment, we found the ratio of output to input. So we just have to know the relation between the two ratios, which is obviously governed by the reciprocity theorem. Okay, so according to reciprocity theorem. So earlier, according to reciprocity theorem, the two ratios are equal. The case before that also the two ratios were equal. But this time, what is the difference between this case and the earlier two cases? In the earlier two cases, at both the ports, we connect the same type of source, voltage source, voltage source. Another case, current source, current source. But here, at both the ports, we have what? Different types of sources. At both the ports, we have connected what? Different types of sources. So at both the ports, when you connect different types of sources, then according to reciprocity theorem, the two ratios are negative of each other, not equal to each other, but they are what? Negative of each other. So V2 by I1, V2 by I1, when I2 is made 0, is equal to what? Minus I1 by I2 when V1 is made 0. So you can see the two ratios are negative of each other. This is what reciprocity theorem tells us. Okay. So how do you summarize reciprocity theorem? First of all, this reciprocity theorem is applicable only for resistive networks that contain two ports. Okay, resistive two-port networks, and at each port some independent source will be connected, and there will be three possibilities: voltage source, current source, and then voltage source, current source. Okay, so when you connect the same type of source at both the ports, the two ratios are equal. Whether it is voltage source, or current source, the two ratios are equal. Okay, ratio of output to input in each experiment, and in each experiment only one source will be kept active, the other source on the other side will be made 0. Yes, and then when you have voltage source on one side and current source on the other side, then the two ratios are negative of each other. That is what is reciprocity theorem. Okay, so I'll just illustrate the application of reciprocity theorem for a simple resistive network. Then we'll look at a few problems related to what? Reciprocity theorem. Okay. Okay guys, let's say this is what the resistive network. Is it not a resistive network? Because inside the box we have nothing but resistors, nothing else. Okay. And is it a two-port network? Definitely. So these two terminals will form one port. Just a second. And these two terminals will form what? Another port. So this is what, like port 1, and this is what? Port 2. Now if you are applying reciprocity theorem, what is it? At each port you have to connect some voltage source. At each port you have to connect some independent source. Let us say at port 1, let's say at port 1 I connect a voltage source, and I call the voltage source as what, V1, okay. And let's say at port 2 I connect what, a current source, and I call the current source as what, I2. Let's say this is what, the complete circuit or the original circuit where we have a resistive network with 2 ports, and at each port some independent source is what, connected, okay. Now the other variables that you need to show are what, at each port you have to show voltage and current. At port 1 already voltage is shown, you have to show what, I1, and you have to mark the direction of I1 such that it flows out of the plus terminal with respect to what, the source, okay. So this is how you mark the direction of I1. Now at port 2 also you should show what, V2 and I2. Already I2 is present. What you should show is what, V2. Again, polarity of V2 should be such that for the independent source the current flows out of plus, okay. So this is how you mark V2. Now for this original network, now we need to perform 2 separate experiments. In each experiment, one source will be kept active, the other source will be made 0, okay. So in experiment 1, the voltage source V1, let's keep it active, and the current source I2, let's make it 0, okay. So when you do that, so first you draw the resistive network as it is, and then at port 1 whatever voltage source that we have, it is kept active. So I draw the same voltage source V1, and at port 2 whatever current source we have, we make it 0. When you make the current source 0, it becomes what, an open circuit, but always you can measure the open circuit voltage V2. Now this V2, is it not the drop across R2, and also R1 and R2 will be in series because the current in this branch is what, 0, since this is what, an open circuit. So R1 and R2 are in series across what, voltage source. What takes place, voltage division will take place. And the other point is what, this V2 will act as what, output, and V1 will act as what, input. So what is the ratio of output to input in this first experiment? Is it not V2 by V1 when I2 is made 0? Now what is V2? Voltage division, V1 times R2 by R1 plus R2. So this ratio will be what, R2 by R1 plus R2. Anyway, this is what the ratio of output to input in the first experiment. In the same way, let us perform the second experiment, and this time the current source I2 will be kept active and the voltage source V1 will be made 0. Let us again draw the original network. So the original resistive network will always remain the same, R1, R2. Right hand side, the current source, it is kept active. So right hand side, we have to connect what, the same current source I2. Left hand side, the voltage source V1, you make it 0, then you know it becomes a short circuit. Then it becomes a short circuit, okay. And through a short circuit, always some current can flow, and that current will flow in the direction of I1. So here also you take the current, you take the short circuit current in the same upward direction, okay. So here, first of all, this current source will act as what, input, and the short circuit current will become what, the output, okay. So here in this circuit, if you observe, R1 and R2 are in parallel across what, the current source. Two resistors in parallel across current source. What will take place? Current division will take place. So this current is what, I2, which will get divided between, you know, R1 and R2. So what is this current through R1 in terms of I1? Is it not minus I1? Because I1 is what, flowing in this direction. This current is what, in the opposite direction. So this current will be what, like minus I1, okay. So according to current division, the current through R1, will be what? Proportional to R2. That is what we know from current division. Which current is getting divided? I2. Current through R1 will be proportional to what? R2, and then divided by R1 plus R2. And in the second experiment, let us again write the ratio of output to input. Output is what? I1. Input is what? I2 when V1 is made 0. So already we have the relation between I1 and I2. So what is I1 by I2? It is minus R2 by R1 plus R2. So the ratio in the first experiment is what? This. The ratio in the second experiment is what? This. So what are these two ratios? Are they equal or negative of each other? Clearly these two ratios are negative of each other. It should be right because we have a voltage source on one side and current source on the other side. Different types of sources at both the ports. The two ratios will be negative of each other. I hope you have understood how reciprocity theorem has to be applied. Okay. Okay guys, look at this problem. So there is what? A resistive network. There is also what? The same resistive network. Yes. So this box contains what? Resistors. So inside the box you have what? Resistors. Okay. And two different cases are given. In one case, on the left hand side we have what? Voltage source, and on the right hand side the current in this branch is given. It is what? Some 5 amperes. In another case, on the right hand side we have what? A voltage source, and on the left hand side we do not have any source, and the current in this branch is what? Some I0, and that current is what we should find. Okay. So always, you know, for reciprocity theorem, for the original circuit we conduct two separate experiments. Yes or no? In case of reciprocity theorem, first we have what? A original resistive network, resistive two-port network, and in that original resistive two-port network you will have two sources, one source on one side, another source on the other side. And for that original resistive two-port network with two sources, we will conduct two experiments. In each experiment only one source will be active. Okay. So if you look at the first case, there is the only source that is present. Right hand side, no source. If you look at the second case, right hand side we have what? An independent source, but left hand side we don't have any source. So the given two cases might be the two experiments that are performed on some original resistive network. So whatever two circuits are given, they might be the two experiments that are conducted on some original resistive network. So from the two cases, you should try and draw the original resistive network. Okay. So from this, let us draw the original resistive network. So one thing is clear, that on the left hand side we have what? A voltage source. On the right hand side also we have what? A voltage source. So this voltage source, when it becomes 0, you get this short circuit. Yes or no? You get this short circuit. And this voltage source, when you make it 0, again you get this short circuit. Yes, so this R1 are identical, this R2, this R2 are identical. So one thing is clear, in the original circuit, on both the sides we have what? Voltage sources, okay. So with this understanding, I'll just draw the complete original circuit. So left hand side we have what? A voltage source. That voltage source, we'll call it what? V1. Along with the voltage source, we also have a resistor R1. This is what? The resistive network. Right hand side, we have what? A resistor R2 and also a voltage source. Voltage source V2. Okay. That's all. This might be the original circuit. Okay. You also show the currents. Always for the voltage source, we show the current to be flowing out of plus, and this current we'll call it I1, and this current we'll call it what? I2. Yes, that's all. So if you look at this circuit without the independent sources, you only have resistors, okay. Yes, except for the two independent sources, we have what? Two resistors R1, R2, and also this box which contains what? Resistors. So overall it is what? A resistive network. So definitely we can apply that reciprocity theorem. Now what is that reciprocity theorem? We have voltage sources on both the sides. If you have voltage sources on both the sides, that means the same type of source on both the sides. Same type of source on both the sides, the two ratios are going to be equal. Same type of source on both the sides, the two ratios are going to be equal. Okay. So what are the two ratios? In one experiment, if you make this voltage source V2, it becomes short circuit. Then the short circuit current is what? I2, but the other side voltage source V1 will be kept active. I2 by V1 when V2 is made 0 is equal to what? In the other experiment, voltage source V2 will be kept active. The voltage source V1 becomes 0 or short circuit, and the current in this short circuit is what? I1. So I1 by V2 when V1 is made 0. So this is the result that we have from reciprocity theorem. Now we should relate this result with the given two cases. Okay. So compare the original circuit with this circuit. Okay. So this is what, in the original circuit that we have drawn, I2 is what? In the upward direction. So here also you have to take I2 in the upward direction. In the original circuit, the polarity of V1 is what? Plus at the top, minus at the bottom. So this is what? V1. Okay. So what is I2? I2 is what? Minus 5 amps. What is V1? It is what? 10 volts. Okay. And then if you compare the second case with the original circuit, yes, 20 volt source is similar to what? V2. V2 polarity is what? Plus minus. So here also you write plus minus, call this V2. So what is V2? It is what? 20 volts. Original circuit I1 is what? Flowing in the upward direction. So here also I1 will flow in the upward direction, which is same as the direction of I0. So I1 is same as what? I0. That's all. So volt and volt, 20 by 10 is what? 2. So I0, it is what? Minus 10 amps. So this is how you apply reciprocity theorem. Okay. So always be careful about the polarity of the voltage drop and also the direction of the current. That is where everybody will make a mistake. Okay. Alright, please look at the second problem. So once again we have what? Two networks. Both the networks are almost identical. This box, both are identical. Yes. R2, R3, here also R2, R3, 2R, R, 2R, R, R1, R1. Okay, all are identical. In the first circuit, there is only one independent source, that is what, this 5 ampere current source. And here we have an open circuit. In the second circuit, here we have what, a current source, and here we have what, an open circuit. Okay. So the given two circuits are the two experiments that are conducted on some original circuit. So let us draw the original circuit. Okay. Let us draw the original circuit. So what could be that original circuit? Look at this. So first I draw the resistive network, that is what, the box. So this is what, 2R. Then this is R. This is R1. This is R2. This is R3. Yes. Now we have to show the two sources. Now we have to show what? The two sources. Okay. So definitely on the left hand side, we have what, a current source, because in one case we have the current source, and when that current source becomes zero, then only you get this open circuit. So one thing is clear, that on the left hand side we have what, a current source. Let's call the current source as what, some I1. Okay. Right hand side also, in this case we have what, a current source. In this case we have what, an open circuit. So when this current source becomes zero, then only you get this open circuit. So right hand side also we have what, a current source. That current source, we'll call it what, I2. So there is a case where on both the sides we have what, current sources, I1 and I2. You should also show V1 and V2. So V1 will be like this, V2 will be like this. So in for both the sources, you can see the current direction is such that it flows out of plus. I1 flows out of plus, I2 also flows out of plus. Okay. Alright, so in this way we draw the original circuit. Now what is reciprocity theorem telling us? Because you have the same type of source on both the sides, the two ratios will be equal. So what are the two ratios? So what are the two ratios? In one experiment, you keep our current source I1 active, current source I2 you make it 0. Then V2 by I1, when I2 is made 0, is equal to what? V1 by I2 when I1 is made 0. V2 by I1 when I2 is made 0 is equal to what? V1 by I2 when I1 is made 0. Okay. Now you have to compare the two experiments with this result that we have from reciprocity theorem. Okay. So in the first case, I2 is made 0. Yes. And then we have this open circuit. So this voltage drop is what? V2, same as this one. I1 in the original circuit is what? Upwards. So this is what? I1. So what is V2? It is what? 200 volts. 200 volts divided by I1, which is what? 5 amps. In the second case, I1 is made 0. That is why you get this open circuit. And voltage across this open circuit, we'll call it what? V1. Yes. And in the second case, this current source I2 is what? Active, but the direction of I2 in the original circuit is what? Upwards. So here also you take the current direction to be upwards. So what is the value of I2? It is what? Minus 10 amps, because I2 is upwards, 10 amps is what? Downwards. So from here we can find the value of V1, okay, which is minus 400 volts. So what is the value of V1? It is what? Minus 400 volts. The question is what? To find V0. Okay. What is this current? It is what? 0, because it is open circuit. So what is the drop across R1? It is what? 0. So what is the drop across R? This is V1. In between the drop is 0. So this drop is also what? V1. Okay. Now this current will be same as what? This current. Okay. Let us call this current as IA and this current as IB. IA equal to what? IB. Okay. IA equal to what? IB. What is IA? It is minus V0 by 2R. What is IB? It is V1 by R. Okay. So that means what? V0 equal to what? Minus 2 V1. Already we know V1 is what? Minus 400. Minus 2 times minus 400. So the value of V0, it is what? Plus 800 volts. What is the value of V0? It is plus 800 volts. So it is quite simple to know that the value of V0 is what? 800. But is it plus 800 or minus 800? That is the tricky part. And that is where you have to be a little bit extra careful. Okay. So what is V0? It is 800. So even if you know reciprocity theorem, but if you get the answer as minus 800, then it is what? Incorrect. Okay. Look at the next question. So here also two different circuits are given. The question is what? To find I0. Okay. So if you look at each circuit, in each circuit only one source is present. Here source is present, here nothing is present. And in the second circuit, here we have a source, left hand side there is no source. Okay. So definitely these two circuits must be the two experiments that are performed on some resistive two-port network that has two sources. Okay. What are the two sources? Here we have what? A voltage source, and here there is no, here we have what? A short circuit. So left hand side we have what? A voltage source. Right hand side here we have what? A current source, and if this current source becomes 0, then you get this open circuit. So clearly on one side we have what? A voltage source, on the other side we have what? A current source. Okay. So let me draw the original circuit. So first we have what? The resistive network. So this voltage source V1, we'll call it voltage source on the left side, we'll call it what? V1. And this current, this resistor is what? R1. This is R2, R3, and then on the right hand side we have what? A current source, which is what? I2. That current source is what? I2. Alright. So now that we have drawn the original circuit, but still you have to show, left hand side we have V1, but you have to show what? I1. I1 will be in this direction. Right hand side we have what? I2. You still have to show V2. V2 will be having polarity like this. So that the current is what? Flowing out of plus. Okay. Now, what is reciprocity theorem telling us? Reciprocity theorem tells us that when you have different types of sources on both the sides, this time we have what? A voltage source on one side and a current source on the other side, then the two ratios are negative of each other. So in one experiment, current source I2 becomes 0 or open, then that open circuit voltage V2 divided by the other voltage source V1 when I2 is made 0. It is what? Negative of the another ratio. Voltage source V1 when it becomes 0, it becomes short. So I1 by I2 when V1 is made 0. That's all. Now you have to compare this result with the two experiments that are given in the question, and then you can find what I naught. So in the first first given circuit, left hand side voltage source V1 is present. So this is what V1. Right hand side the current source I2 is made 0. So this is what that open circuit voltage V2. So what is V2? It is 5 volts. What is V1? Same polarity, it is what? 100 volts. This is what? Negative of I1. And in the second case, voltage source V1 is made 0 or short circuit, and the short circuit current as per the original circuit will flow in the upward direction. So what is I1? It is minus I0. So I1 is what? Minus I0 divided by I2. What is the direction of I2 in the original circuit? Upwards. So here also you take I2 in the upward direction. So the value of I2 is what? 20 amps. So minus of minus is what? Plus. So I think I0 is what? 1 ampere. So what is the value of I0? It is what? 1 ampere. Okay. Yeah, it is 1. So the value of I0 is what? 1. So here the important thing is what? This minus sign. Okay. Because you have different types of sources at both the ports. The two ratios will be negative of each other. Okay. Look at the last question. So what is given? Some resistive network is given. In the first case, on the left hand side, we have applied what? A 10 volt source. In the right side is what? Open, and the open circuit voltage on the right side is what? 3 volts. Okay. And the current drawn at port 1, current drawn by the resistive network at port 1, it is what? 5 amps. Okay. That is the first circuit. In the second case, the box is what? Same as before. So this box is same as what? This box. Same resistive network. And this time on the right hand side, a current source is connected. And on the left hand side, we have this extra 2 ohm resistor. Okay. And then the current through this 2 ohm resistor is what? Some I0. The question is what? To find I0. So first of all, you should understand that there is not straightforward application of reciprocity theorem. Why? Had it been straightforward application of reciprocity theorem, then here instead of 2 ohms, you should have had what? A short circuit. Yes or no? I mean, originally you might be having a voltage source here, and if this voltage source becomes 0, you would get a short circuit. But here you don't have a short circuit, you have an extra resistor. So it is not simple and straightforward application of reciprocity theorem. That you should understand first. Okay. But somewhere you have to use reciprocity theorem. Look at this. Please look at this. So this is what? Case 1. So this is what? The first circuit. This is what? The first circuit, which I have drawn it as it is. Okay. What is this yellow color box? This yellow color box, is it not a linear one port network? This blue color box is what? Resistive 2 port network, but this yellow color box, it is what? A linear one port network. Yes. So this is what a linear one port network. Are there any independent sources inside this yellow color box? No. Resistive network will only have resistors, and then here we have what, an open circuit. There are no independent sources inside the yellow color box. Okay. So you can think of this 10 volt source as what, Vt, and you can think of this 5 amp current as what, It. So what is Vt by It? It is what, 10 volts by 5 amps. What is Vt by It? If you have a linear one port network and then you apply a voltage source Vt, and if there are no independent sources inside the network, and the ratio of Vt by It, Vt to It, is it not the Thevenin resistance? So this 10 volts by 5 amps, which is 2 ohms, it is nothing but the Thevenin resistance. It is what? The Thevenin resistance of this yellow color box. Thevenin resistance of the yellow color box. Okay. So what is our goal? Our goal is to replace so let us replace it with its Norton equivalent. Let us replace it with its Norton equivalent. Okay. So we are replacing this green color network with its Norton equivalent. What is a Norton equivalent? You will have a single resistance Rn. In terms of value, Rn is equal to what? Rth. Now this green color box and the yellow color box, the Norton resistance, the Thevenin resistance, will it not be equal? Because while finding Thevenin resistance, you make the independent sources 0. Yellow color box and green color box are identical when you make this current source 0. Please understand this. Inside the green color box, there is this current source, but inside the yellow color box, there is no current source. So if you make this current source 0, then the green color and yellow color boxes are identical. Then the Thevenin and Norton resistances will also be equal, because while finding RTH or Rn, we make the independent sources inside the network 0. Yes. Already for the yellow color box, we found that the Thevenin resistance is what? 2 ohms. So this would also be 2 ohms. Okay. Now the other thing you have to find is what? The short circuit current. Yes, and the other thing you have to find is what? The short circuit current, that is what? IN, which is same as what? ISC. The Norton current, which is same as what? ISC. Okay. And then across this, we still connect the same 2 ohm resistor, and this current is what? I naught. I hope you have understood what we are trying to do. Okay. So once you find, so already in this network, 2 ohm resistor, 2 ohm resistor values are already given or already known. So the only thing we have to find is what? ISC, the short circuit current. So what is that short circuit current? So for the green color box, this 2 ohm resistor is like the load, and when the load becomes short circuit, whatever current flows in the short circuit, that is what is the short circuit current. Okay. Please look at this. So the first circuit is same as what? The first given circuit. Okay. And the second circuit, I replace the 2 ohm with short circuit, because I told you what? For this green color box, This 2 ohm is like the load, and we are finding what the short circuit current through the load, for which we can make the 2 ohm a short circuit. Okay, so when you make the 2 ohm short circuit, you get this short circuit. Let the short circuit current be some ISC. Now, okay, so this is also what the same resistive network. Yes, now we can apply reciprocity theorem to find what ISC. So find ISC using what? Reciprocity theorem. Find ISC using reciprocity theorem. Okay. So these two circuits are the two experiments that are conducted on a original resistive network. Okay. So what could be that original resistive network? First experiment, this side we have what a source, this side we have what open. Second experiment, this side we have a current source, this side we have what a short circuit. In fact, this voltage source, when it becomes 0, you get a short circuit. This current source, when you make it 0, you get open. So clearly on one side we have what? A voltage source, on the other side we have what? A current source. So the original network, or the original circuit, can be something like this. So this I will call it I2, and the voltage source connected on the left side we will call it what? V1. Polarity of V2 will be like this, direction of I1 will be like this. So this time we have a voltage source on one side and current source on the other side. Voltage source on one side, current source on other side. Different types of sources on both the sides. The two ratios will be what? Negative of each other. Okay. So what are the two ratios? V2 by V1 when I2 is made 0 is equal to what? Negative of the other ratio, which is I1 by I2 when V1 is made 0. Now you have to compare this result with the two experiments. Okay. So this is same as what? V2, and this is same as what? V1. So what is V2 by V1? It is 3 volts by 10 volts is equal to what? Negative of, what is the direction of I1? It is what? Like this. What is the direction of I2? It is what? In the upward direction. So what is I1? It is minus ISC. So minus of minus ISC, the short circuit current, divided by I2. This I2 is same as what? The direction of 6 amps. So is what? 6 amps. So 6 into 3. So from here the value of ISC is what? It is what? 18 by 10, which is 1.8 amps. So the value of ISC, it is what? 1.8 amps. That's all. Now in this circuit, we know the value of ISC, we know the value of RN or RTH, which is 2 ohms, and the load resistance is what? 2 ohms. So what will happen in this circuit? This IN, the short circuit current, will get divided between the two 2 ohm resistors equally. So I0 is what? ISC by 2. Yes or no? So from here, definitely I0 is what? ISC by 2. So I0 is what? ISC by 2, which is 0.9 amps. So this circuit can only be solved when you use both reciprocity theorem and the Thevenin's theorem. So we have used Thevenin's theorem to find the Thevenin resistance, and we have used reciprocity theorem to find the short circuit current or the Norton current. and then we replace this green color box with its Norton equivalent short circuit current in parallel with the Norton resistance, which is same as what the Thevenin resistance, and then we treat this 2 ohm resistor, the extra resistor, as what the load. Yes or no? Because in the first circuit the 2 ohm resistor is not present. In the second circuit only we have this extra 2 ohm resistor, so that is treated as what the load. So once you replace the remaining network with its Thevenin or Norton equivalent, we can easily find anything for the load, either the load current or the load voltage. Okay, is it clear? So this is how you apply, this is how you apply reciprocity theorem to any resistive two-port network. Okay, so always in the equation two different circuits which are nearly identical will be given, and from those two circuits you just have to visualize or imagine the original circuit. Then for the original circuit, from reciprocity theorem we have what the result, and that result should be related to what the two given circuits. Okay, that is how we do it. I'll end the session. Afternoon I'll take the next session. Okay.